I want to take this moment to talk specifically about this particular format of the function of a line, and that's the slope-intercept form of a line. The slope-intercept form of a line has its advantages and its disadvantages. Obviously, advantages are it's a very simple equation. We have two things, two unknowns. We have a slope and we have an intercept that we just need to find. Now, the slope is pretty easy to find. We just do our rise over run. If I had a ruler, I could measure how far it goes up between this point to that point, and I could say that's my kind of change in y. And I can figure out how far it goes from here to here, and that's my change in x. No problem at all. But the y-intercept can be tricky, because if this piece of our function is really far away from the y-axis, I'm going to have to extrapolate this point all the way over, potentially a long way. Okay, I may have to travel way over here, and then maybe the y-axis right there. Maybe I finally found it. Okay. And I could say, oh yeah, there's my b, there it is. There's my y-intercept, I guess. But look how far I had to go to find that. So graphically that could be a trouble. Mathematically, that could also be trouble. So I'm going to suggest that the slope-intercept form of a line is not necessarily ideal. If you are close to the y-axis, if the y-axis actually goes through right there, oh, then b is right there and it's easy. But if you're far away from the y-axis, this could be a tedious numerical approach.